Okay, so find the volume of the solid generated by revolving the shaded region about y-axis. So this is the shaded region. When you revolve this shaded region about the y-axis, whatever volume will be generated, we are interested to find the volume of that portion. So let's draw that thing here, and this is what we would like to find out. When you revolve this around y-axis, we can use a cylinder like this. This is the part we can use at a point on this curve, and then the distance of that point from the y-axis, this one, is x, which is actually the radius of this cylinder. So we can find the volume of this cylinder by finding this integration pi r square. This is actually the area of this part, the area of this cylinder when we the area revolving when we revolve this region around the y-axis. Pi r square is the cross-sectional area of this part, and when you integrate from 0 to 1, which is 0 to 1, y equal 1 is given, that gives us the volume. So this is the formula we're going to use in this problem. Because the function we're using is tangent function, so we are using this standard formula for integration of tan square, which is 10, and then here is the variable x I'm using for the formula. So this is the standard formula you need to use. So in this case, x is 4tan pi over 4y. So if you go to the next slide, here volume equal pi r square. R is given, which is the value of x. If you square it, that would be 16, and then there is a pi 10 square, and then this value inside. So here, to find the integration, we have to substitute for this internal thing. So I'm going to use u equal pi over 4y. By doing that, I'm changing this limit of integration as well. When y is 0, which is lower limit, u is, just replace this y by 0, it will give you u equals 0. And when y is 1, the u would be pi over 4. So when we change variable y to u, then limit of integration would change from 0 to pi over 4. And we also have to replace this dy by du. For that, let's differentiate this thing with respect to, let's do the derivative both side, and that will give us du equal pi over 4 dy, and if you solve for dy, that will be 4 over pi du. So we are going to plug this value here, and when we do that, this portion now changes to 0 to pi over 4. As you can go here, y equal to 0 gives you u equal 0, and y equal 1 gives you u equal pi over 4. So I am changing this limit of integration from 0 1 to 0 pi over 4, and I'm going to replace this by u and this dy by 4 over pi, and just do the simple simplification here. This cancel this pi and this pi. 16 times 4 is 64, and now we need to find the integration of tan square u. By using the formula, integration of tan square u is 10u minus u, and then by using the fundamental theorem, we just have to plug u equal pi over 4 and 0 here. By doing that, when we put u equal pi over 4, that would be 10 pi over 4 and minus u equal pi over 4. And now when we plug 0, tan 0 is 0, u 0 is 0. So after simplification, 10 pi over 4 means 1. So 1 minus pi over 4, and then after simplification, the answer would be 16 times 4 minus pi. So if I use this answer here, 16 times 4 minus pi, that is the answer I'm looking for. Check the answer, and that's right.